maybe I will get into more detail later. I have another slide for that. And then another concept introduced in this revision is the maximum profile. So this is also to answer one question. So some of the system vendors ask me, so many different kind of NIC. How should I make a base for motherboard to support all of them or most of them? And well, the easy answer for me, okay, you just so many 3D, then you just figure out how do you make it work. So to make it more scalable, we also with context help, we build a maximum profiler. So I call it M1 and M2 is the mapping to M1 mapping to type 1 NIC and the M2 mapping to type 2. So what it does is simply just overlay all the typical type 1 or type 2 mezzanine NIC implementation, but overlay the 3D in the same model, and then come out a suggestion of how do you make the base for outline to accommodate all of them. And then 1.00. 1.00 was posted right before the Christmas break. So, and it is approved by the IC last month. So it is official now in the wiki page. And not much update from 0.95 to 1.00, only some typo correction or minor fix. And there is already something coming. This is actually a topic that we trying to get into 1.00, but we didn't manage to meet the time. And this is to aid the two kinds of new implementation example. So it doesn't break much of backward compatibility thing, but it will allow you sure example of how do you implement a KR Mezz with 4 RJ45 and with LED building. And the 1.00 already have the implementation example with the LED not in the RJ45 page, but so I will try to make this submitted to the work group and the IC to see do we need a full review or with just minor accommodation. Okay, so I think and then next thing we will spend some time trying to explain what NIC is, where it comes from. So take a step back is before NIC we have Connect A and Connect B. And originally we only have one connector called Connector A, and that's supported by PCIe. And then Connector B was added earlier last year in order to extend the bandwidth of the PCIe to about 16. And meanwhile, with the Yosemite system that Ian just introduced in this room half an hour ago, the KR Mezzanine car with the Yosemite need some KR signal to get into the mezzanine connector. So at that time, we defined in a kind of flexible way that there is 16 PCIe lanes, so you can use the top, say top X number of lane as PCIe, then the bottom 16 minus X number of lane be used as KR. However, there is no sideband signals. By sideband signal, I mean such as NDIO or some LED signals built into the Connector A and B. And what Yosemite does is using BMC to handle many of those sidebands and job. And then last year we in the community mainly I hear common interest from Intel and Quanta to have a more dedicated KR interface, and their requirement is they want to have sidebands. So maybe from a chipset or from the NIC that they have some native sideband, they want to talk to the PHY on the KR Mezz. And Connector C is the answer for that question. And so the Connector C, I want to get into a little bit more detail first on the electrical and then on the mechanical. So electrically, Connector C is intended to support up to 4 KR, 10 gig KR, so it's not ready for 25 gig KR, and The reason is the connector, work stack connector we use are not suitable for that application. And it also includes the sideband signals, such as LED, I2C, and the software-defined pin usually for presence of the SFP class module. It works independently, which means the NIC already including power, ground, and signals, and it's not using any power from the connecting. It doesn't have to use for this one. So that for a mezzanine card, it is okay for the mezzanine card to only populate or design in connector C and only function. That's the intention. And on the baseball side, you can, if you only want to support the KR Mezz with the connector C, then you can only go with connector C. And if you want to support both the general PCIe NIC and the KR Mezz, and it's okay that you populate all three connectors. And that's actually lead to the mechanical. So the intention when we enable the connector C is trying to make it mechanically backward compatible as the highest possibility. So the location of connector C is picking at that location in order to not change the outline of the mezzanine part. So you can see the connector C is actually inside the coastline of the mezzanine NIC itself, so it doesn't increase larger PCB. And the other is we did some height limitation change and check with the NIC vendor out here in the NIC component height in the connector C area, and we adjusted the height in the area from 4.5 millimeter in the past to 4 millimeter. The intention is to let those components on the NIC not hitting connector C when you have a type 1, type 2 stack, because A-4 is 4 millimeter and the connector C is 3.7.